I'm going to go through this question in two different ways. First of all, this is how I did it. We've got a large circle and its radius is 2, which means the circumference is 2 pi r, so it's going to be 4 pi, which by the way means that half the circle is going to be 2 pi. For the smaller circle, the radius is 1, so the circumference is going to be 2 pi times 1, or 2 pi, which means that half the circle is then pi. The cars are moving round in the way shown, this figure of 8, around like this. So there's only two ways that they could collide. They're either going to collide at this point, and I'm going to leave that for the moment, or they're going to collide when y catches up with x, because we're told that y is moving faster. So first of all, let's look at when y catches up. So to catch up, y must move an extra 3 pi, because it's got its starting point, it's got to get along pi and another 2 pi to get to where x was. Okay, x is going to be moving as well, but y is going to have to move that amount too. So for x, I've got its speed, it's going to be its distance moved divided by its time taken. That's not particularly useful, but when I go to y, we're told that it's twice as fast, so 2v is going to equal the same distance that x has gone plus this extra 3 pi, and it's got to do so in the same time. Now I can now solve these to work out what d is. I can multiply this one by 2, so 2v is going to equal 2d divided by t. I only need to times the top by 2. If I times the bottom as well, then I wouldn't change the fraction. And then I can equate this and this. So 2d divided by t is equal to d plus 3 pi over t. In fact, I can just cancel the t's out, minus the d from both sides, so d equals 3 pi. That makes sense, doesn't it? Because y is 3 pi behind, and so in the time that it takes d to move 3 pi, if y is going twice as fast, it will move 6 pi. So that is going to be probably our answer. The only thing we have to justify to ourselves is that they don't collide here. And we can do that by just considering what is going on. So y is going to move pi in the time that x only moves pi over 2. In fact, it's only going to go a small amount. And then y is going to be sort of catching up as x moves. And it's behind it now, but it's definitely going to catch up before x has moved this full 4 pi. You can just sort of see that by looking at it. So I feel like that's enough of justification for why they're going to collide when y catches up rather than in the middle. Now the official answers to this question in a sort of a similar kind of way, except they don't go for the speed time formula like I did. They start off with the beginning diagram and then note that y will move to here in the time that x just moves a small amount. In fact, we could keep a little running total. So we've got pi and just a half pi. And then up here, I think it's been 2 pi and pi, then 3 pi and 1.5 pi. You can just sort of keep adding a little bit on every time, remembering that x has moved half the amount. Then we're up to 4 pi and 2 pi, 5 pi and 2.5 pi. And we're going this way round. And then they're going to meet at 6 pi for the white car and 3 pi for the other one. So that is where you can get 3 pi from as well. It's a good approach. It works quite well here. Quite like my approach as well. Well done on this question.